So we previously found that two derivatives of r in this time parameter minus r d theta d tau squared is equal to 0. That's what the geodesic equation reduces to. That's just a statement that in the radial direction, the acceleration is equal to 0. And so now we want to see that the other component, which is d2x1, d tau squared plus gamma, in this case 1, beta, well, gamma, we're using that as a index as well, dx gamma d tau, dx beta d tau. We want to evaluate this. We want to show that this will be the conditions on the two derivatives in theta such that the angular acceleration is 0 as well, because we have 0 acceleration here. So this becomes, well, let's evaluate the individual connections now. So we have gamma 1, 0 gamma, dx gamma d tau, dx 0 there, plus, now we have 1 here, and so we have 1 there. And now we have to sum on gamma. So this is this, which now becomes, so this is first 0, so we have 1, 0, 0. That must be 0, and so is that, plus gamma 1, 0, 1. So this is 1, and this is still 0, plus gamma 1, now we are here, 1, 0, dx 0, d tau, dx 1, d tau, plus gamma 1, 1, 1, dx 1, and same here. And so again, now we are going to evaluate 1. This is the same as this. These two connection coefficients are the same. So we need 1, 2, and 3. So gamma 1, 0, 0 is 1/2 g. Sum on that index. We have this one as 1. D g 0 b dx 0 plus dg 0 b dx 0 minus dg 0, 0 dx b, which is 1/2, and we know that it's only b equals 1 that survives here, so we really only have one term to consider. This is 0, 1, so dx 0 plus dg 0, 1 dx 0 minus dg 0, 0, respect to dx 1. These metric components are individually 0, whereas this one is a constant, so its derivative is 0, so the entire thing is equal to 0. So let's move to the 1, 1, 0 or 1, 0, 1. And here we have 1/2 G B1 d G0B in X1 dx0 minus dg01 dxb, which is 1/2 g11 dg01 dx1 plus dg11 dx0 minus dg01 dx1 So let's see here. Again, we only have one term to consider. This is 0 by itself. This is 0 by itself. This is r squared, and we're taking derivative with respect to r, so we end up getting, so we have 1/2 g11 times dg11 with respect to x0, or x0, and that's 1/2. G11 is the inverse of G11 lower, so that's 1 over r squared. And so the derivative of G11, which is r squared, with respect to r is just 2r. And so we get 1 over r as a result of that. And gamma 1, 1, 1 looks like 1/2 GB1 dg1b in x1 or theta plus dg1b in theta minus dg11 in xb, and of course the only one to consider is g11 upper, so we get dg11 with respect to x1 plus dg11 with respect to x1. None of these, the g11 doesn't depend on theta, so it doesn't depend on x1, minus dg11. So all of this is 0. And so what we get is d2x1, d tau, plus 2 times 1 over r, dx1 d tau, dx0 d tau is equal to 0. That's the same thing as saying second derivative of theta in this time parameter plus 2 over r d theta d tau dr by d tau is equal to 0, or second derivative is equal to minus all of this. But this is just the acceleration in the theta direction. And so that's also equal to 0.